The supercharged 719cc Kubota diesel-powered Honda Insight is taking the week off while it gets upgrades to increase the boost developed by the supercharger. Don't worry, the car will be back on the road soon. In the meantime, now would be a great time to finish the repairs on this abandoned Honda Insight that we recently purchased. This first-gen Insight is actually a complex car, and in order to troubleshoot the various problems we found, we're going to be using this very affordable Ancel Diagnostic tool, so we can repair this car the first time at minimum expense. So the Ancel scan tool is an up-to-date and feature-packed diagnostic aid to help you navigate through the various subsystems found in modern cars. If used correctly, a tool like this will save you a fortune. And today, I'll show you how we use this tool to troubleshoot and repair our 25-year-old Honda. Not exactly a modern car, but this tool also works great on older cars as well. If something like this appeals to you, then check out the video description for a link. Oh, one more thing. This Ancel V5 BT uses a Bluetooth interface dongle, which later in this video, you'll see this feature comes in handy. Alright, let's get started. To begin our diagnostic procedure, the first thing we need to do is plug the dongle into the OBD2 port on the car. Once the dongle is plugged in, you should see a red LED illuminate. This means the Bluetooth dongle is now drawing power from the car's electrical system and it's broadcasting its Bluetooth signal. Next, we have to turn the ignition on, and this will power up all the modules in the car, including the ECU for the engine. Over in the upper right corner, you can see that the scanner has automatically connected to the car via the Bluetooth module. And also note, the scanner is reporting that the car's battery is at a satisfactory voltage. Now, since this is an in-depth diagnostic procedure, we went ahead and connected a battery charger to maintain optimal voltage throughout the testing. This is always a good idea to do. At this point, we're ready to have some fun and try to figure out why the starter and the fuel pump on this car are not working. So this is actually difficult to film, and to give you folks a better view of what's going on, I'm going to be using the screen capture feature that's built into the scanner. Okay, that's a lot better. So as you can see, this scanner has a huge database, and it can connect to pretty much any car on the planet, including some cars I've never heard of. At this point, we're going to dive deep into the ECU and look at various signals that may be causing our starter and fuel pump issues. So we'll select the data list. Now this is basically all the input and output signals that the ECU is looking at. A lot of this stuff is actually fun to look at when the engine's running. However, right now, we're going to be looking at some basic info. So the first thing we want to know is the status of the immobilizer. On a lot of modern cars, the immobilizer can cause starting issues. Next, we want to have a look at the signal driving the fuel pump relay. And now we should select the starter control and the starter switch. And for fun, let's grab the brake switch, the neutral position switch, and I don't know if these two have anything to do with our problem, but let's look at them anyway. And the last item we need to look at is the clutch pedal position switch. This guy definitely could be our problem. Okay, the fun begins. So right away we can see the immobilizer seems to be happy, and it's showing we're good to go for engine run. Now if this was a problem, the V5 BT has a feature to register a new ignition key on the ECU, which is a cool feature and it'll save you a trip to the dealer. Anyway, it looks like we're good here. Let's look at some other signals, and for that we'll need to sit inside the car. Just for fun, let's check the brake switch. I don't think this is even close to being our problem, but let's look at it anyway. Well, the brake switch works, so that means we're getting valid data from the car's ECU. Now let's check the clutch switch. And this may actually be part of our problem with the starter. Well, it looks like we have a good clutch signal, so we can rule that out. And again, just for fun, let's check the neutral position switch. And sure enough, it's working as expected. I reckon now we need to verify the starter command is getting to the ECU. And right away we are seeing nothing. Sometimes on these cars, you have to hold the key in the start position a lot longer so the ECU can figure out what starter to use. Yeah, on this car it has 2 starters. And nothing. Alright, well that's interesting to know. Now for the fuel pump command signal, that's going to be a bit tricky to capture that one. So the best way to see the fuel pump signal is to switch the ignition off and then back on again. But we can't do that because that'll interrupt the data stream to the scanner. Now this is the fuel pump relay, and it tests fine on the bench. And we even substituted another relay to confirm the circuit is not working. So down here is where the fuel pump relay plugs in, and in the previous video, we verified that the relay isn't getting a command signal to prime or run. The good news is the fuel pump works fine, and we're able to get the car to run by placing a jumper across the terminals that supply the fuel pump with power. Actually, the entire circuit for the fuel pump was heavily scrutinized in the previous video, including verifying that the ECU is actually generating the command signal, and we were able to measure that with a DVM directly at the ECU. The bad news is the signal just isn't getting to the relay. So for now, we'll use a jumper to provide the power for the fuel pump so we can continue with the diagnosis. Now, to make matters worse, the starter also doesn't work, so we'll temporarily use this remote starter bypass switch. Alright, what we want to see is if the ECU will send a command signal to the fuel pump relay once the engine's running. Like I mentioned earlier, this signal is tricky to capture, but we should be able to see it once the engine's running. And sure enough, once the ECU registers the tachometer signal, it figured out it would be a good idea to turn on the fuel pump. ECUs are smart like that. So from our diagnosis, we determined that the starter signal isn't reaching the ECU, and on this car, that's the way the starter circuit is wired, and that's because this car has two starters. Anyway, the ECU is located under the carpeting in the footwell, and I reckon the wire for the starter switch is located behind the dashboard, and it's also possible the wire for the fuel pump is also under the dashboard. So... Off camera, I went ahead and removed the dash so I can inspect the wiring harness, and sure enough, I found evidence that a rodent had made a home up under the dash and chewed through some of the wires. Here, let's take a closer look. So after doing some digging, I found two damaged wires, and according to the factory service manual, one of these wires is the command signal for the fuel pump relay, and the other wire is, well, you guessed it, the starter command wire. Given the amount of debris and feces I found, this is likely damage from a rodent or possibly a marsupial of some kind, but definitely not a cow. Yup, it's a mess, and I cleaned up all the debris and other stuff, so it's safe to go ahead and repair the harness. As most of you folks know, this car is a gasoline-electric hybrid, but this is a very special kind of hybrid, and what that means is this car will function pretty much normally without any of the hybrid stuff working. Also, Honda did everything possible to reduce the weight on this car, including using wiring that's a bit on the smallish side, but still thick enough to carry the current required by each circuit. Anyway, off camera I spent a lot of time inspecting every inch of the harness for any damage, and the only area that I could find was this area that I'm now repairing. Now this wire has a gash in it, but as far as I can tell it's still working. At some point down the road, this may actually become a problem, so I'll cut out the damaged area and splice in one more repair. To speed things up, I'll do that off camera. Okay, the wiring repairs are done, and I went ahead and put the fuel pump relay back in its position. The remote starter switch has been removed and the starter has been reconnected into the car's harness. I reckon now we need to see if the car will start normally. You folks ready? And that was not expected. You see, yes, the engine started, but the starter didn't actually do anything. It looks like the hybrid electric motor actually started the engine. That's interesting because I was under the impression that the hybrid stuff on this car didn't work. Now I guess that's good news, but at this point I don't trust the hybrid stuff, and I want to see if the normal, or as it's referred to as the backup starter, will work. So to turn off all the hybrid stuff, I think all I have to do is flip this switch and the car should operate in gasoline mode only. Let's try that. Okay, stand by for ignition. Yes, the backup starter seemed to work as expected. However, I did have to hold the key in the start position for a few seconds before the ECU commanded the backup starter to work. So if I flip this switch back on, I guess that'll turn on all the hybrid stuff, which appears to actually work. This car may not be in as bad shape as I originally thought. Let's give it another shot. Yep, the hybrid stuff works, and we don't have a check engine light. Not too shabby. Whoops, it looks like I spoke too soon. We do have a check engine light. Well, no big deal. We can use the Ancel OBD2 scanner to have a look at this problem. And as a bonus, the scanner will also check out the hybrid system for fault codes. Give me a moment to put all this stuff back together, and we can continue with the diagnosis. Okay, the car is mostly back together, and now it's safe to drive. I reckon we should take a look at what's causing the check engine light to come on. Okay, this top one is telling us the catalyst isn't functioning properly, and that may be due to the other codes that are present, so we'll ignore this for now. This guy, well, I'm pretty sure it was due to the intake air sensor being disconnected when I removed the air filter to gain access to the starter motor. This sensor has been reconnected, and I don't think we need to worry about it right now. This one is interesting. Now, on this car, the oxygen sensor in the S1 position is not a normal sensor, and it's actually a wideband oxygen sensor, which means it's going to be expensive if it's bad. Keep in mind, this car was way ahead of its time when it was introduced back in the day, and Honda decided to use a wideband sensor to measure the air-fuel ratio so they could do some tricks to improve fuel economy. I guess it worked because these cars get a minimum of 50 miles per gallon, and if driven with some care, it's not unusual to get over 60 miles to the gallon or more. You know, I've seen accounts where folks are claiming insane numbers that approach 100 miles per gallon. I think I would hate to be behind one of those drivers. Anyway, let's clear these fault codes and set the scanner up so we can take the car on a road test. Okay, cleared. Alright, let's grab the engine speed, the vehicle speed, heated oxygen sensor S1, and this is the wideband air-fuel sensor that's evidently suspect. And let's get the air-fuel feedback command for fun. And I guess we should grab the second oxygen sensor that's placed after the catalytic converter. Okay, you folks ready for a ride? Well, as I sit in front of the video editor, I can see problems already. The wideband air-fuel sensor on this car works a bit differently. I'm not going to get into all the details, other than the air-fuel ratio signal is measured in milliamps. And right away, we can see the sensor stuck at 10.40 milliamps. Now, in reality, I don't think that's what's actually going on. I'm pretty sure the ECU gave up using the air-fuel ratio from the wideband sensor, and it's using backup data to keep the engine running. The 10.40 milliamps is likely the ECU broadcasting the last known PID before the ECU switched over to backup data. Fortunately, I'm using the screen capture mode on the scanner, and I have my eyes on the road and not on the scanner. And this goofy driver just made it to my YouTube channel. Oh, hello, you need to get in front of me? You know, you're on YouTube. This road test is pointless without valid air-fuel sensor data. However, I want to show you something else that happened. Hopefully you can see the engine RPM. And it drops to 0. Of course, at the time this happened, I wasn't sure what was going on, but as soon as I put the car in gear, the engine automatically started up again. Oh yeah, this is a hybrid. I'm not sure I like this feature, and I reckon it can get annoying real fast. Now, both on and off camera, I was able to determine that the hybrid stuff on this car actually works. So on acceleration, there's a boost in power as the electric motor kicks in, and when the brakes are applied, the regen kicks in. Probably some more stuff happened, but honestly, I have no idea how to drive this car. You see, it's a bit too fancy for me. And I'm back. That road test went on for a long time, and I'm not sure anybody wanted to see all of that. Anyway, the wideband oxygen sensor is real easy to get to on this car, so I pulled it out to take a look at it. Really not much to look at other than the sensor's not carbon fouled. Now, during the road test, I did stop a number of times and cleared the trouble codes with the scanner, and it seemed like the longer I ran the engine, the longer the sensor would work without triggering a trouble code. Eventually, I was able to drive the car without the check engine light coming on. Now, does that mean this sensor's any good? Hell no! According to the part number that's stamped on the sensor, this is an OEM part that was installed on the car way back in November 1999. So this is nearly 25 years old, and it has 250,000 miles on it. I think it's time to retire this part. Now, I did read some folks will use propane torches and do all kinds of shenanigans to get these sensors to work again. And that's fine, a little tinkering is always good. But for me, well, I'm not going to stand on my head, spit nickels while rubbing my tummy to get this sensor to work. Meh, I'll bite the bullet and pay for a new one. And since this is an early production car, the sensor's different than what's installed on later cars. I might as well get a new sensor while they're still available. Now as for the rest of the car, I did a deep dive on all the systems and scanned each one. The hybrid drive system is clear of trouble codes, and while I was there, I looked at all the signals and data the hybrid or IMA modules were sending. Anyway, all this hybrid stuff actually has a clean bill of health. The ABS brakes, well, same thing, all good. Plus, this scanner can activate the pump and the solenoids, and that'll make bleeding the brakes a lot easier. And just for fun, I looked at the data from the electronic power steering. Meh, it's hard to get excited about that, but the scanner was able to display that as well. All in all, this is a cool tool to have if you own a car that's not powered by a lawnmower engine. Anyway, I'd like to thank Ancel for letting us use this gadget for today's episode, and I hope you folks enjoyed something a little bit different, and we'll see you next time.